Well, we've learned to solve inequalities. We've learned to graph compound inequalities. Now we're going to put them together. We're going to learn to solve compound inequalities. So before we do that, let's just do a little recap. Solving an inequality. Let's take 3x minus 7 is less than 8. Remember, to solve an inequality, you solve it just like it's an equation. That means I'm going to add 7 to both sides. I'm going to divide by 3. Then I always graph and check the solution. So there's my graph. Remember, use an open circle if the point isn't included in the graph, and a closed circle if the point is included. Okay, so I just said that you solve it just like an equation. There's one difference, and that difference has to do with negatives. Look at 3 is less than 5. That's a true sentence. What if you multiply both sides by negative 1? Then you have negative 3 is less than negative 5. That's not a true sentence. So in order to make it a true sentence, you would have to reverse the inequality symbol. So you had negative 3 is greater than negative 5. So basically what that means is whenever you multiply or divide by a negative number, you have to reverse the inequality. So look at an example here. If I'm solving this inequality, I'm going to solve it just like an equation. So it means I'm going to subtract 5 from both sides. But now I have negative 2x is less than 2. I want to divide by negative 2, but that means I need to reverse the inequality. Okay, remember to graph it and check it. Just a little bit about checking. To check, remember you select any point in the solution set. Don't select the endpoint, but pick something close to the endpoint. So looking at x is greater than or equal to negative 1, I'm going to select a point near negative 1 on the graph, so in the solution set. I'm going to pick x equals 0. It's pretty close. So I start with my inequality. I substitute. That's true. That means that my solution checked and my graph is correct. Okay, now let's get to the real stuff, compound inequalities. How do I solve them? Well, first of all, what is it? A compound inequality is an inequality that contains at least 2 inequalities, and they're combined by either the words and or. Remember that and represents the intersection of the 2 inequalities. Both parts have to be true. And or represents the union of the inequalities. It has to make at least one of the 2 inequalities true. So look at 2x is less than 10, or x divided by 2 is greater than or equal to 3. I start by splitting it up into 2 inequalities. So I have 2x is less than 10, or x divided by 2 is greater than or equal to 3. Solve both of the inequalities, just like we've been doing. So that left side gives me x is less than 5. On the right side, I'm going to multiply both sides by 2 to make x is greater than or equal to 6. Okay, so we start by graphing it. Remember, when you graph it, you graph both inequalities, and then you check to make sure they're both correct. That checking takes care of the checking of the inequality also. So when you check this time, don't go and check into x is less than 5 or x is greater than or equal to 6. Go back and check into the original compound inequality and make sure that whatever point you pick makes, because it's an or, at least one of those 2 inequalities true. And remember to write your solution set. Don't make the reader guess what the solution is in this case. So you want to write out the solution set. All right, here's the second example. This time I have a compound inequality that's a combined inequality. Combined inequalities are always and statements, only exist when you use the word and. So you need to break it into 2 inequalities to solve, just like we did before. The important part is this 9 plus n. 9 plus n belongs to both of the inequalities. So when I break it up, I get 1 is less than or equal to 9 plus n. 9 plus n goes with that. All of 9 plus n goes with the first part. And because it's a combined, I know it's an and statement. 9 plus n again, take everything within those inequalities is less than 18 minus 2n. So now again, I solve both of those inequalities like we've been doing. I'm going to subtract a 9 from both sides. And I'm going to rewrite the inequality so that the variable comes first because it's easier to graph. Solving on the other side. So now I'm ready to graph it. Let's just do a little recap on that. So originally I had 1 is less than or equal to 9 plus n is less than 18 minus 2n. When I solved it, I got two inequalities, n greater than or equal to negative 8 and n less than 3. So I start by graphing n greater than or equal to negative 8. I'm going to graph n less than 3. Now remember, I don't really graph on a new number line. I'm doing that just to show you. I actually graph it right above. And now, because it's an and, I'm looking for when it makes both of those true. That's going to be the intersection of those, which is going to be this section between negative 8 and 3, including negative 8. Remember to check it. And checking it means putting values in and making sure the original inequality is true. And then finally, make sure you write your solution for the reader. Don't make them guess. In this case, I wrote n greater than or equal to negative 8 and n is less than 6. I could also put that back in combined form and write negative 8 is less than or equal to n is less than 6. All right, that's it for this lesson. We will have some practice problems for you. And remember, if you have any questions, talk to a math teacher near you.